Do you love math? If you do love math, I suggest to go to www.mrmathinc.net or YouTube Mr. Ing today. Very easy and compatible to work with.
Alright, let's go over 3.5 to find the number of positive, negative, and also imaginary zeros. So I'm going to go to this dark mode here. Alright, state the possible positive real numbers, negative real zeros, and imaginary zeros. So let's do this problem with me here. And for the positives, all we have to do here is count the number of sign, which is positive negatives, changes. So x to the fifth here is positive. So going from here to here, we would say yes, that's a change. No, because it's negative, 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 positive, that's a yes. Positive, negative, that's also a sign change. And this one, actually, sorry, this should have been a positive. And so negative to positive, that's also a yes. So if I count the number of changes here, I have 1, 2, 3, 4. So with 4 sign changes, that means the possible positive zeros can go from, they go in pairs. So 4, 2, or 0 is our answer. Okay, for negatives, we're going to do the same thing. We're going to count after f of negative x, which basically means we're going to put in a negative x for each of these values. So just kind of minus 2 to the x to the 4th power minus x to the 3rd power plus 6x squared minus 5x plus 10. So basically what I did there is I'm going to put in now negative x for each of these values, and we're going to simplify. Now remember, we're going to do PEMDAS here. So that means we're going to do the exponent first. So negative 1 to the 5th power, you're going to get negative x to the 5th power. Negative x to the 4th power is going to be x to the 4th times negative 2 is going to be negative 2x to the 4th power. Negative x to the 3rd will be negative x to the 3rd, and the opposite will be a positive x to the 3rd. Negative x squared is going to be x squared times 6, so it'll be positive 6x squared. And that'll be positive 5x plus 10. And then we're just going to do the same thing, is we're going to count the changes. So this would be a no, yes, no, no, and this would be a no. So here you'll see that there is only one sign change, which basically tells us that there is one negative real zero. Let's put a box around that. Okay, so what we've done so far is we've taken this polynomial and we're trying to figure out the possible positives. So we looked at the positive sign changes, then we look at the negative possible negative zeros by putting in negative x. And now we're going to figure out how many possible imaginary zeros, okay? So let's put up a chart here. And we'll call this one positive reals. We'll call this one negative real zeros. We'll call this one imaginary zeros. And we'll call this one total zeros. So just a quick conceptual will help us make sure we're on the right page. We have x to the fifth. I'll get a different color here. So it's an odd degree polynomial. And I'm just going to draw something really quickly. The positive real zeros basically means when it crosses in quadrants 1 and 2. The negative real zeros, it's what's coming from down here. And the pink one I can't even show you, but it's basically when it doesn't touch the x-axis. I guess I didn't do a great job of that, but see if we draw this one down here. And so this one you realize doesn't touch the x-axis. That's an imaginary zero. Okay. All right. So let's do. Let's put our puzzle pieces all together. So let's go back over here. We said 4, 2, 0. Okay. We have 4, 2, and 0. And then we said we had 1 negative real zero. Okay. So we just have to do some easy math operations here. 4 plus 1 plus something equals, well, the total zeros comes from this one, the highest degree, which is a 5. So these will always be an equal to a 5. Well, 4 plus 1 plus 0 will give us that equals to 5. Do you see how that works? Okay, so let's do the next one. Guess to color code this should all have been blue. Okay, 2 plus 1 is only 3. That means this one has to be 2. So 2 plus 1 plus 2 equals 5. And then the last one, 0 plus 1 is 1. So that means this one would be 4. So let's quickly review our positive real zeros. In the first column, we have here that it has 4 times. So if I had to draw that, that would be kind of like, well, I'm not going to show you, but just making a quick chart right now. We're just trying to figure that out, okay? All right, let's go ahead and go on to question number 10. G of x. Okay, let's do our positive zero. So yes, no, yes. So we have 2 here, positive. This is going to be 2 or 0. Let's do our negatives. We're going to put in negative x for each of the x values. Sorry, allergy season. And let's just simplify this. Negative x squared is x squared, so negative 4x squared, positive 17x plus 6. So no, yes, no. Sorry, just double checking all my work here. Negative x to the third times 3. Negative is positive. Okay, so that means for the negatives, negative real zeros, we have only 1. So if we make our chart, positive, negative, imaginary, and total. So our total has to be 3. And positives, we said either 2 or 0. So I guess I don't need that last one. Negatives, we said that there is 1. So that means 2 plus 1 plus 0, or 0 plus 1 plus 2 will equal my 3. So those are the total combinations for our graph that we'll eventually draw. Okay, so if you had to write that out, it would be positives, zeros, and then imaginaries would either be 0 or 2. All right, number 11. Let's get our positives. So this is a plus, so this would be a yes, yes, yes. How many yeses we got? And you just count down by 2s here. So this would be 3 or 1. All right, let's do the same thing with our negatives. I'm just putting in negative x here, and then count the sign changes. Let's simplify it first. So negative x to the third, that'll be positive x squared, so negative 8x squared minus 2x minus 4. No, no, no. So negative real zeros, we have 0. Okay, so if I make my chart, I got positive, negative, imaginary, and total. So my total is going to be 3. Our positives are 3 and 1. Our negatives is going to be 0 and 0. So that'll be 3 plus 0 plus 0 equals 3. And 1 plus 0 plus 2. So that means our imaginary zeros are going to be 0 or 2 of them. Number 12. This is a plus, so this would be no, no, yes, positive, real zeros are just going to be 1. Let's put in our negative x. And let's go ahead and just simplify here. So this will become x to the 4th. Remember, if you get confused on this, you can actually just put in negative 1 in for negative x and then see your outcome for the negative portion into your calculator. So this will become positive x squared minus 3x minus 9. So this would be a no. Sign change, yes. No. That means I only have negative Real zeros is only 1. Then if we make our chart, positives, negatives, imaginary, total, net, pet. Okay, so our highest degree here is 4. So if I do 1, and then 1, that means that number must be, it's either going to be 2 imaginaries. Zeros. All right, question number 13. Let's take a look at the number of positive changes, sign changes. Yes, no, no, no. So our positive real zeros is going to be 1. Let's put in negative x. Remember, you have to use order of operations here. So we're putting in negative x, and then we'll simplify and then count the number of sign changes. X to the 4th, negative x to the 3rd power is going to be negative x to the 3rd power times a negative 5 is going to be a positive x to the 3rd power plus 2x squared minus 5x plus 7. So this is a positive, so here we have no, no, yes, and yes. So we have negative real zeros. We're going to have 2 or 0. Actually, I made a mistake looking up. That one should be yes, right? So that one should be 2 or 0. 2 or 0. Positive, negative, imaginary, and total. So our total is going to be 4. And how do you know how many to write down here? Is because, if you look at the positives, you have 2 and 0. Does this make sense? And there's 2 numbers. Well, the negatives, I know based off of the positives. And they also have 2 or 0. So then we just add these. 2 plus 2 plus 0 equals 4. Or 0 plus 0 plus 4. I think I'm missing a combination here. Let's just say this one was 2, because that still equals 4. Oh, I see it. You could have had 2 here, or 0, because then this one could have been 0, or this one could have been 2. Does that make sense? So I do have to think about all the combinations. So the imaginary zeros is going to be 0, 2, or 4. But don't worry about duplicate there. All right, number 14. Count sign changes. Yes. No. Yes. So positive real zeros are going to be count by 2, so 0 or 2 here. Let's stick in negative x. And simplify. So that would be negative x to the 5th power, so that'll become positive. Plus 5x to the 4th, plus 4x squared minus 8. So no, no, and yes. So negative real zeros are just going to be 1. Okay, let's make our chart. Positives, negatives, imaginaries, and total. So our total is going to be to the 5th power. Our positives are going to be 2 and 0. Our negatives are going to be 1 and 1. So 2 plus 1 plus 2. And 1 plus 0 plus 4. Okay, imaginary. Zeros are just going to be 2 or 4. That's our answer. And number 15. Let's go ahead and count the sign changes. 1, no, 2. So positive real zeros are going to be 0 or 2. So I got the 2 that I counted right here. 1, 2. And you have to count in pairs for the positives. Let's do the negatives. I'm going to do that by putting in a negative x for every x value. Simplify, so this will be 4x to the 6. And not a trick, but basically every time it's even, it's just going to be like a negative x times negative x times negative x times negative x. So it's going to stay the same. That's what I'm trying to tell you. Here's an even. It's going to stay the same. Not stay the same. It's going to do the opposite of what's in that parentheses. Hopefully you understood what I was trying to say. Okay, this is a positive, so yes, no, yes. So 1, 2, so negative real zeros is going to be 0, 2. We've got to count by pairs. Positive, negative, imaginary, total. So the total is going to be 6. I think we're going to have at least 2. So our positives, 2 and 0. Let's see what happens here. And then our negatives. Okay, this is why I realize we need to have, let's see, watch. Because you could put the 2 here, or the 0 here. Or you could put the 2 and then 0 there. Because this would be 2 plus 2, that would be 2 imaginaries. You can have 6 imaginaries. You can have, whoops, that's a plus sign, 4 imaginaries. Or 4 imaginaries. So the imaginary zeros are going to be 2, 4, and 6. You just have to think of all the combinations. And that's how you do that problem set. We'll see you guys later. Bye.
2 plus 2 is 4, minus 1, that's 3 quick maths. Everyday man's in the class, doing problems. He that problem board, that problem is easy, thanks to Mr. English.